Today we're going to look at examples 4 and 5, graphing a function and its numerical derivative of section 3.2, numerical derivatives and limits from business calculus with Excel. The idea is to graph a function f of x and its numerical derivative f of x plus 0.001 minus f of x minus 0.001 over 0.002. F evaluated a little bit after the x minus f evaluated a little before the x divided by the distance between the before and after. There's going to be 3 basic steps, 3 pages, a basic setup page of what we're going to do for all these functions. Then we're going to graph with a simple function, a quadratic function, and look at the graph of the quadratic function and its derivative. And then we're going to look at what we have to do a more complicated function. The simple function is example 4, the more complicated function is example 5. For our setup, we're going to want to know what the function is and what the distance is, how far before and after. And so I have an initial x, and for my graph, what's the next step? I want to know x plus delta x and x minus delta x, f of x. Then I'm going to evaluate that at x plus delta x and x minus delta x using quick fill. I take the difference of the two values of f over twice times the delta x. That'll give me the numerical derivative. So this is a basic setup that we're going to use time and time again and just have to fill in, change a value, and do the quick fill. So this is something worth committing to memory of how to set it up. What I really want is f of x plus delta x minus f of x minus delta x. So I want those two evaluated, which means I want x plus delta x and x minus delta x, and that is based on x. So now we're going to look at an example where we've done that. I'm going to show my formulas. And if I look at my formulas, when I'm trying to graph the function and its derivative, we'll notice that I have f of x filled in, and I'm going to get rid of these two. F of x was filled in with my function, and part of the reason I wanted x plus delta x, and x minus delta x in this order is then when I quick fill, this will evaluate the function at the corresponding spots. That gives me everything I needed in the first row. I quick fill down to get the second row. And now I'm going to say, I've got 2 points that I want. I'd really like to graph this from 8 to 12, going up by 1. I've set up how far my step size is. I go down till 12. That fills everything in for me. I'm going to unshow my formula so I have numbers. And now notice I have the graph. So I have the graph of the function f and the graph of its derivative. And we're going to look and notice that at the point that the function changes from decreasing to increases, the derivative, looking at the scale over here, that's where it changes from negative to positive. And that sure looks like a straight line. So I can make conjectures that if I have a quadratic function, I should get a straight line as the derivative. But part of the reason for setting up this template is I started it with a nice simple function. I'd now like to look at example 5, where I have a less friendly function. Again, I'm going to look at my formulas and see my formula is x cubed times quantity x squared minus 36, x cubed times x squared minus 36. I've already done the quick fill I needed there. I'm going to unshow my formulas. So I take this and quick fill down. I'm now, in this case, going to want to go from minus 6 to 6 by 0.5. I have my step size. I quick fill down to 6. That gives me the chart I want now. So I'm going to simply do x, hold down the command key, f of x, hold down the command key again, f prime of x. I want to insert the chart for a marked scatter, and I get my function f of x and f prime of x. So I could use the same template with basically any function, that if I had just wanted to make this an x cubed minus 25, changing the function, I need to change this to x cubed minus 25. Enter that in that one point. It's a really different kind of number because we're going to 6th degree. I quick fill in for the function, quick fill in for the other things, and f prime shows up. So again, I can use this template and graph f and its numerical derivative in the same graph. Thank you.